Okay, there are a few things that we want to go over when we're talking about something called Coulomb's law, and the title, How Close Can You Go? So it turns out that the electrostatic force felt by the objects is dependent upon how close the two objects are and what charge each object carries. The equation that we use for this is FEL equals KQ1 times Q2 divided by D squared. Force, just like we discussed before, is what we see with abbreviated by the letter F. So F stands for the force. And the EL subscript is talking about the electrostatic force of attraction or repulsion. Q, as we saw from this front side of this, Q is the variable for the abbreviation for the variable of charge. So how much charge an object has. And there's Q1 and Q2 because generally when we're talking about the force, we're talking about the force between two charged objects. D is the distance. That's on the denominator, so the further away two objects are, the less force they will feel. The last one that we see up here is K. K is written down here for you. The constant, right, because constant starts with a C, so we use the letter K, and it was found to be 8.98755178736817764 times 10 to the 9th Newton meters squared per Coulomb squared. Because that's such a long, ridiculous number, we'll just round it and use K as a value of 9 times 10 to the 9th Newton meters squared over Coulomb squared. Again, those units are there because they will cancel out our other units, leaving us with newtons as our force unit. So kind of something to be aware of. Okay, quick check. If a balloon carries a charge of negative 2.6 times 10 to the negative 6th coulombs and it is brought near a Van de Graaff generator, those are those big metal things that kind of shock people, that has a charge of negative 1.4 coulombs, which object will experience the greater force of repulsion? We know that they're both negative, so they will repel, but which one will experience the greater force of repulsion? Take a second and think to yourself what that would be. Pause if you need more time. What we can remember from our unit earlier with forces, if these two objects are a force pair, the force is on the Van de Graaff by the balloon, and the force on the balloon by the Van de Graaff. That is that we call the Newton's third law pair. So the electrostatic force will be the same for both. So whatever that force felt by the balloon will also be felt by the Van de Graaff generator. We just don't see the same force because we see motion, which does have to relate to their mass. All right, the next part. The force in Coulomb's law stands for the force felt in any direction. The force will be calculated as a negative number if the force is, and positive if the force is blank. You don't need to memorize this factor as a result seen. It is a result seen from inputting the correct negative and positive signs on the charges. So if I were to put two negative values in here, a negative times a negative, that will give me a positive value. So two negative charges will repel, and a positive force value will seen if the force is repulsion. And therefore, if I have a positive and a negative charge in my two Q's, positive times a negative will keep the number negative, leaving us with a negative force, which will represent attraction. So again, you don't really need to memorize this. It's just something that results from inputting these. If you should know that a positive and a negative charge will attract, and a negative and negative will repel, or a positive and a positive will repel. So that is the part you should know. Using this equation isn't much different than things we've done in the past. So the first question says, a balloon with a charge of negative 4.0 times 10 to the negative 5th coulombs is held a distance of 0.1 meters from a second balloon having the same charge. Calculate the magnitude of force. So we are looking for the force. You can write out your knowns. We do know that Q1 is equal to negative 4.0 times 10 to the negative 5 coulombs. Q2 is the same, so that is also negative 4.0 times 10 to the negative 5 coulombs. The distance is 0.10 meters, and we are looking for F. So F is what? Or FEL. Coulomb's law is given to us. K times Q1 times Q2 divided by D squared. I can plug in my values for K. K is 9 times 10 to the 9th Newton meters squared per Coulomb squared. We're multiplying that by our charge 1, so Q1 is negative 4.0 times 10 to the negative 5th coulombs, times Q2, which is negative 4.0 times 10 to the negative 5th coulombs, all divided by our distance squared, so 0.10 meters squared. A good thing to point out here is that the distance must be in meters when using this constant. Because meters are over here, our distance must always be plugged in as meters. Our charge must always be plugged in as coulombs. We can't use electrons, we can't use centimeters. After solving this in the calculator, 9 times 10 to the 9th times negative 4 times 10 to the negative 5th times negative 4 times 10 to the negative 5th, all divided by 0.1 squared, we get a value of 1,440 newtons. So that is your electrostatic force. The force in this problem is repulsive. And that's all for this video. Enjoy doing the rest of the worksheet.